Let's talk about differentiating between the different types of test and test statistics you would calculate for the different types of hypothesis test in Chapter 8, and then also which function you would use on the calculator. So anytime you're doing a hypothesis test where you're testing a parameter and that parameter is a population proportion, then you're always going to perform a z-test. And that means that you're going to approximate using the normal distribution. So because it's a z-test, your test statistic is going to be a z-score. If you're using formulas, that formula is going to involve your sample proportion. So a p-hat, and that's going to be p-hat minus your null hypothesis value, p-naught. Divide that by the square root of p-naught times 1 minus p-naught all over your sample size. Now, if you're using your calculator to do a hypothesis test about a proportion, and this is for one sample, then you would use the one proportion z-test on your calculator. So this is a good way to remember when to use this particular function on your calculator. You're going to use it when you're trying to estimate for one sample proportion, and you're doing a z-test, and that test also means you're doing a hypothesis test. Okay? All right, if you are doing a hypothesis test and you're testing a claim about some population mean, so some average, and the population standard deviation, which we call sigma, if it's given to you and it's known, then here you would also perform a z-test. And a z-test means we're going to approximate with the normal distribution as well, okay? The test statistic is also going to be a z-score, but this z-score is going to involve a sample mean. So we're going to have x bars. We're going to see the difference between your sample mean and your null hypothesis value, mu sub 0, divided by the known or given population standard deviation, which is called sigma. So that's the Greek letter sigma. Divide that by the square root of your sample size. On the calculator, the function you would use here is you would perform a z-test. So a z-test is the test that you would use if you're doing a hypothesis test and you're testing a claim about a population mean and sigma is known. But what happens when you're testing a claim about a population mean, mu, and sigma is unknown? In this situation, you would always perform a t-test. So a t-test means we're going to approximate with the t-distribution, and the t-distribution involves you knowing your degrees of freedom. So remember, the formula for degrees of freedom is always your sample size minus 1. And so the test statistic for this distribution is going to be a t-value. That formula is going to involve your sample mean. You see how far away it is from the null hypothesis claim or null hypothesis value, mu naught, and divide it by the sample mean divided by the square root of the sample size. So notice that this test statistic does not involve sigma because sigma is unknown. If you're using your TI-84 calculator, the function you would use here is t-test. T because we're using t as your test statistic, and test because you're performing a hypothesis test.